So we've got how much energy does it take to melt? This is now latent heat, and specifically it's latent heat of fusion. This little F means latent heat of fusion, and we're talking about the amount of energy to either melt or the amount of energy to melt something, or the amount given off when something freezes. Okay, so amount it gives out when something freezes, and what it's saying is that 334,000 joules would be needed to melt a kilogram of ice. Okay, so that's the specific latent heat there. Now, when you are melting or boiling something, the temperature does not change. So there was a graph that you may have looked at a while ago, and it looks a little bit like this. Let's say that's the time taken to do something, and over here, that's the capital T is temperature. Okay, and what happens is as we heated something up, the temperature increased. No surprise there. But then for some reason, it suddenly goes flat. So I don't know if you remember that, learning about that, but that does happen. And then it starts to increase again. And then it goes flat again. And then it starts to increase again. Now the reason for that is because what we're doing at between these points here is we're heating up the ice, if we're talking about water here, and then between this point here, we are melting the ice. And then we're heating up the water, and then we're boiling the water, and then we're heating up the steam. Now, as I said in question 2, when you're heating up something and it's staying the same state of matter, the temperature increases, the kinetic energy increases, but you're not breaking any bonds. So what you're doing when you're changing the state is you're breaking the bonds, and so no temperature increases because there's no change in kinetic energy. Okay.